Okay, number one, which graph represents f of x? It's a piecewise defined function. We've got the absolute value of x up top when x is less than 1, and then we've got the square root of x when x is greater than or equal to 1. So the main difference between these two is that, there's a lot of differences, but here we're going to have a linear function, and here we sort of have our sideways parabola. Right? The square root function is like if we turn the parabola on its side. So one's going to be curved and one's going to be linear. So this top function, absolute value of x, is going to be linear, and that's only when x is less than 1. So as I'm going through my choices, 1, 2, 3, 4, I'm looking to see if that left side of the graph represents a linear function. So for 3 and 4, I have the same type of graph that looks more like a parabola. So I can eliminate those right away. Here for 1 and 2, I can see that these two are linear functions. So between the two of them, I have to see when x is greater than 1 for that domain, which of these two have a root function. And here I can see that 1 has that, that curve of a root function, that sideways parabola. Number 1 here, that's just a straight line going up, so that would not be a root function. So 2 would be the correct answer here. All right, number 2, a function is graphed on the set of axes below. Here we've got another piecewise function and what looks like a parabola turning into a just a linear function. And notice there's an open hole at 1. So the function has no value at 1. So which function is related to the graph? All right, so for f of x, the first choice, again, it's being defined as a piecewise function. So I'm going to look at the first part for all my choices. I see x squared when x is less than 1, x squared when x is less than 1, x squared when x is less than 1, and x squared when x is less than 1. So it's the same thing 4 times. So that's not going to be very helpful in narrowing my choices down. Instead, what I see is that the second part of the piecewise function for each is different than the first. So one thing I'm probably going to do first to help me figure it out is I'm going to look at the slope of this line, because all of these line segments here have a different slope. So to find slope, I just locate 2 points on the graph, and I'm going to find my rise over run. So I rise 1, run 2, so that would be a slope of 1/2. And only choice 2 has a slope of 1/2, so it'll also be choice 2 for this, right? This has a slope of +1, slope of 2, and a slope of 3/2. Those do not correspond with the picture. Number 3, when the function g of x, where the function g of x is equal to 5x when x is less than or equal to 3, and it's x squared plus 4 when x is greater than 3. Is graphed correctly, how should the points be drawn in the graph for an x value of 3? So 3 is sort of that dividing line for the two piecewise functions, where 3 will be filled in for this top one, and it'll be a blank hole here. So I'm just going to plug 3 in for both. So 5 times 3, that'll be 15. So 3 comma 15 is going to be included. So when it's included, it's a filled in dot, or they call it a closed circle. So here it says 315 is open, so it can't be that. It could possibly be that. Open circle at 315 certainly can't be that. All right, and here we got closed circle at 315. And I could plug in 3. I'll just do it just to make sure. But really, if the function cannot equal 3 here, it's got to be an open circle. So whatever this point is, I'm going to assume it ends up being 13. They can't both be closed circles because only one of them exists at x equals 3. But just to be sure, I'm going to plug in 3. 3 squared plus 4, that's equal to 13. So my coordinate 3 comma 13 is going to be an open circle. And that's just what we have right here for choice 4.